SwayamPrabha. Digital India. Educated India.
Good morning. Welcome to the NPTEL online certification course on structural systems in architecture. So, this course is a 8-week course, and this course is floated for the students of architecture basically, and this course, as you all know, the NPTEL platform, and this course will be covered the various systems and the applications of the structure in the field of architecture. Let me introduce myself. I am Dr. S.P. Bhattacharjee, Shankhapratim Bhattacharjee. I am a faculty in the Department of Architecture and Regional Planning, IIT Kharagpur. This is my second online NPTEL course. The first course, which was floated the last 2 years, that was the building acoustics with another professor of our department. So, today we will go with the first module and the lecture number 1, that is the introduction to structures, which is the lecture title, and the module 1 we will cover the statics and structural systems which will take 5 lecture of half an hour duration. So, I will going to cover these 5 or 6 concepts. We will start with some kind of the outline of the course, then the key features and the learning objective of the course, then we will define the structures and the structural systems, then we will move into the types of structural systems, and finally, the objective of the structural engineering. So, what are the learning objective of this particular half an hour lecture today is we will initiate the course overview. So, you will have a kind of a understanding the how the course will run and what are the things to be done in the course. Then we will go to the basic understanding of the structural systems, and then we will discuss some of the requirement of the structures in the building, why a structure is required, and what is the consideration, special consideration for the structure has to be taken while a architect decide upon the building design or the architectural design of a building. So, in the course outline, as I discussed, this is our first concept of this particular lecture today. So, we have 8 modules. Each module will run for each week. In the first module, we will discuss the statics and the structural systems, which is the first lecture is today. The structures and its classification we will discuss. We will discuss the force system, then the supports and the reactions, loading, etc. Then the module 2 and the module 3, again 2 of this consecutive week, we will discuss the structural mechanics, the part 1 and the part 2, where the theory of elasticity, the material properties, the bending and the shear, the stresses, different type of stresses due to the bending and the shear, the deflection of the members, structural members, and some of the theory of the columns will be discussed. So, as you all know, the structures, if you try to look into, you have to know about some of the basics of the mechanics and the some kind of the solid mechanics also. So, we will cover these module 1 and the module 2 and also the module 3, the all. The module 4, the 4th week, we will do the frame structure analysis and the design. So, mostly the buildings are of kind of frame structure, as you know. So, what are the methods of analysis, what are the structural element in the frames, and the application of different type of the frames in the architecture, and also the design principles for the RCC and the steel structure will be discussed. Then In the 5th, 6th and 7th module, we will cover the whole lot of the structural concept, application and advantage, disadvantage, some of the case studies for various type of structural systems. That will include in module number 5, that will include truss and space frame, which are the very important two type of structural systems what we see in the today's world. We will also discuss the arch, shell and dome, another category of the structural systems in the module 6, and module 7 we will discuss the tensile structures and the plate structures. So, both the concept we will start with for all the every component of the structural systems, and we will discuss the various applications in architecture through some case studies. The last module, the module number 8 will be deal with the spatial structures. That includes the pneumatic structures, the tensegrity, which are the typical type of structure which sometimes employed in the buildings in a temporary kind of a shelter accommodating people in various forms. And we will also discuss some of the cost effective technology used for the buildings and what are the structural impact of that, how to reduce the cost of the structures, particularly in the domain of the low cost building technology. And we will also discuss the building foundation, because without the foundation, discussion of the foundation, the structure cannot be, the discussion of the structure or the knowledge of the structure cannot be completed. At the end, we will discuss some of the high rise structural systems also, but in a very brief form. So, this is the course outline for the 8 modules. Now, what are the key feature of the course? Let us discuss this key feature of the course, that will definitely going to help you in understanding the how this course will move. As you all know, or as I have already discussed, that this particular NPTEL lecture course on structural systems in architecture is focused or designed specially for the students of architecture BE Arch in various universities and the institute in our country. So, we have to I have taken care of the syllabus of all the institute, almost of all the institute, and as per the guidelines of the Council of Architecture. And we will discuss the concept and through the lectures, and we will actually discuss some of the real life examples through some illustrations, some figures, some kind of notations and all. We will also discuss the theories of structures, or the theory behind the structural systems to be adopted, because without the theories it is very difficult to understand the where and when I will going to use those kind of a structure. Basic theories is very much important. So, we will demonstrate that one, but it will be in conceptual way, and it will have the minimum mathematical computation, because we are not going to deal the structural engineering or this structural systems as a particular civil engineering faculty do for the civil engineering students. So, we have to keep in mind that or I have to keep in mind that I am teaching this to the student of architecture. So, I have to bypass those critical mathematical computations and all, but definitely some simple mathematical things, simple mathematical formula, some of the small algorithms will be discussed in very conceptual level. And the prime focus of this course will be understanding the structural systems is advantage application in the architectural design, because as you all know, the students of architecture basically focus on the design or the architectural design of the building. So, while you will go for a kind of a design based on your design principles and the design philosophy and also the design concept, the building has to be stand by the structural systems. So, I have just now told that there are various types of structural systems you may use for that, but which one will be advantageous, which one will be very much the fit for that particular design, or so that you must understand after this particular course. The learning objective for the course, it will definitely, if you go through all the 8 weeks, if you participate in the assignment, if you participate in our forum and all, it will clarify your fundamentals of structural engineering, clarify the various salient points of the fundamentals in the structural engineering. It will correlate the theories of structure with the behavior of the structure. So, how the structural theories are developed based on the behavior pattern of the particular structure, that we will going to understand. You can analyze and design basic structural element, but of course, this third point will be a bit of in a very simple type of structural element you can design. You cannot, probably not going to design the complicated one. You can compare and evaluate the various structural systems, that is very much important for students of architecture, because suppose for a particular in your design you can apply, or you can actually provide various type of systems, but you have to actually evaluate that, you have to compare that, and then only you can think to provide that kind of a thing. You can apply and appreciate the structural systems into the design of the studio exercise. I have already told that in your studio exercise it will be definitely it will be improved of your structural systems application of that. And definitely the last but not the least, you can perform well in the competitive examinations and the job interviews, particularly competitive examinations. I am focusing the examination like GATE examinations and maybe some other examinations which are going to be asked. They are going to ask some of the basic questions on the structures. Now, let us come to the actual the objective of the prime objective of the lecture number 1. What is the structure, and how you can define a particular structure. The structure of a building or object is responsible for maintaining the shape of the building and to by virtue of some of the loads, the external loads. So, external loads are always going to apply even a particular structure, any kind of a building or maybe any kind of a building. The structures and buildings have some kind of a difference. Suppose building, as you all know, but structures may be a bridge, may be a structure, a transmission tower may be a structure, a dam may be another structure. So, all the structures are having some kind of load, the external load which will apply on the particular object. The loads actions are gravitational load by virtue of its weight, or sometimes some kind of environmental loads like wind, or maybe some kind of the earthquake, or maybe some kind of tidal wave or whatever. So, a structure has to take care of those. It is important that a particular structure as a whole should stand, and also partially or maybe the individual level also should not break down or maybe deformed or with a when this kind of load or forces are applied on. And also this is another important thing is that it should not deflect or break or whatever, but it should actually safely transmit all the loads that come on the building or the particular structural systems, and those resulting force must be grounded properly through some supportive system, which is called actually foundation. And finally, it should maintain the integrity and the serviceability of the build form. Though what is the integrity and what is the serviceability, we will discuss today itself in a little later. So, as I know that if I say now that the definition of the structure which I have just now completed, now what is the structural systems, what is the definition of the structural systems? There is a fine difference between a structure and the structural systems. Any structure is compressed of the structural elements and the non-structural element. I have just in my PPT, I have written down there are some element of the structure which is suppose the beam is one, and suppose the column is another one, slab is something like a two-dimensional thing, truss, you know that kind of a truss is there. So, those are the typical type of structural systems, whereas the partition wall, false ceiling, all those all those door, window, parapet, etc., some flooring, some kind of mock up kind of a wall decor and all those kind of things are come under the non structural element. Now, those structural elements and those, if you now put together all the structural element, you will get the structural system. So, the structural element may be your beam or maybe your column. So, if you just put into this plus put into this, then you will get a particular structural systems also. So, the structural elements and the structural systems has a kind of a differentiation also. So, now let us discuss about some type of the structures which are applicable to different type of systems or different type of the objects. The first of all is the building. Building is one of the key issue in our architecture. So, in buildings, if you see, there are three pictures, and in that the first one, the left side one, is a tall building. So, it has different element, it has different structural systems. The lower one is a in an arena where there are long span long span structural systems, are very lightweight kind of structural systems are required, which is definitely very different from the tall building or the high rise building. And the third one is a structural systems, is a curvilinear structural systems, which is a kind of a arch or those kind of things are there. But if you see all the three, they are actually take care of some of the building or the habitat. There are some towers or the bridges also. The Eiffel Tower or maybe the Leaning Tower of the Pisa is the wonderful example of the structural systems. It still stands for the quite long period of the time. The central picture is the Vidyasagar Setu of Kolkata city, which connects the Howrah and Kolkata over the river of Ganga. So, that is also a fabulous structural systems has been used for that particular bridge. So, the structural systems can be applied for any kind of the buildings, tower, bridges and all. So, there are different type of systems has to be adapted for different kind of the execution or for the applicability. So, now let us see as I understand what are the element of the structures are like beam, column, link, plate, member, cable, like that. So, there are individual items. A beam is individual items, as you know, it is a horizontal item which is a kind of a taking load in the gravitational direction or the downward direction, whereas the column is a vertical member which can take the load, of course, and in a different way, it is through its own axis it can take the load. So, plates are again a two dimensional flat structure. So, those are the elements of the structure. And now, depending upon the geometry and the orientation of those elements, you can have different type of vocabulary, like the thin and thick. What is thin and thick? Suppose a plate or maybe a wall may be thin or thick. Then the grid and the dimensions, this is again a geometric property. What is the grid? That may be what is the center to center distance between the footprint of the column. So, those are the grids. What is the dimension? Then the linear and the curvilinear, just I told you there are the curves, that is the arches and all, which is the curvilinear. Linear may be a straight beam, a straight column may be a linear. Inclined, yes, a wall may be inclined, a plate may be inclined, or maybe a column is also sometimes may be inclined. So, those are a cable may be inclined cable. Then there are some kind of a shapes, triangular, square, the forms like parabolic, yes, a kind of the arch may be a parabolic in nature, a cable may be a parabolic in nature. Then the span, how much is the center to center distance between the supports and the free forms or so. Those are the geometry and the orientations. Now, if you club those together, So, there may be a different type of element and different type of geometrical orientations. So, there may be some permutation combination amongst them, and then you can get some kind of a structural systems or the structural configuration. Now, if you take the structural configuration, the nature of the loading you have to also take care of that. So, is it a concentrated load, is it a heavy kind of a moment, is it a wind, it is a seismic load. So, every loading has its own type of the impact. Okay. So, those impact has to be also taken into account when you are going to select some kind of a structural systems or the configuration. And then you have to again take care of some kind of a material, which type of material you may use for your structure. It may be, if you suppose you are going for a truss, it may be a steel truss, it may be a RCC truss also. So, whenever I am going to have those kind of a material, you need to know some of the material property like ductile property or the ductility or the brittle properties also. And again you should know about the what are the support system, that how finally that particular structure has to be supported through some component, like if it is a simply support or it is a cantilever out or it is a continuous kind of a support or it is a flexible kind of a support. So, those are the typical type of support system. So, what I go back to that, I mean again, so is the elements and the geometry, then gives me the configuration. From the configuration I know that this is the loading type, it is the material I am selecting, and then this is the type of support system, and after all this comes together. So, I can now analyze a particular structure and I will try to assess the behavior of that particular structure. And what is the behavior gives me? The behavior gives me the, is it a stable or unstable? It is a shear predominant things will come, or it is a bending, the bending will come in totality with this particular material loading and the support system. What will be the buckling character? How it will going to buckle? Is it going to buckle or not? What, how much it will deflect? Is it going to deflect much, or it will be under controllable deflections also? Is it going to see, I mean they are going to have some kind of a cracks or no? Sometimes we may allow some non-visible kind of a very micro cracks also, sometimes we may not allow that. So, that those kind of the behavior under those kind of a configuration material and all those gives me some kind of the output, and based on that behavior I will actually now see some of the functions of my architecture. I see the architectural function, I will see the economy, I will see the serviceability, durability, construction technology also I will see. Suppose some of the materials, some of the systems, it is not available in my country or maybe some part of the country. So, it is unnecessary to think of those kind of the structural systems or so. So, again finally, I have to see the aesthetics of the building. So, again this will come into a permutation combination, we will select the typical structural systems also. So, based on that we will going to have some kind of a selection criteria. Now, what are the type of structural systems? If I go one by one, then I may have frames, the building frames. In the lower left corner picture you see, this is a normal type of a building which is having frames. Frames means the column, beam, foundation and the slabs. We may have trusses also, we may have some kind of a trusses also, it may use it for the very long span application. We have sometimes the space frames, which is again in the lower left corner given in a photograph, where there are some kind of the 3-dimensional trusses can be used, and the lower the upper right corner you see the arch form of space frames can be also going to be used. We may have some kind of a structural systems like arches and vaults. Arches in a linear kind of a character, vaults is a 3-dimensional kind of a character. When two such vaults or two such barrels are meeting together perpendicularly, a vault will be created. This particular picture on the vault is the picture of the corridor of the Calcutta High Court. You see how interestingly the pillars, the columns are taking care of the different type of flying arches in the different direction, creating a fabulous interior with vaults. Then there may be some kind of a shell structure. Shell is one way ahead of the arches, which is a 3-dimensional formulation of the articulation of the arches. So, we can have wonderful structure made up by the shells. The lower left corner structure, as you all know, it is the Sydney Opera House, and the upper picture is from our country, the New Delhi the Baha'i temple, or it is famous, it is known as Lotus temple also popularly. We can have the domes also. Domes are used in the architecture if you see the history of the architecture, you will see the lot of in the time period, if you see from the Islamic or pre-Islamic period also, you will see the domes are used as a roof covering, and there are various type of illustration, various type of decorations, various type of form has been developed in the timeline in the history of architecture. So, the lower left corner is the Islamic dome, which is very much predominant in our forms in our India or maybe in any country. And the other one is the Matri Mandir, which is a in Pondicherry, there is a dome is also going to be used for that particular purpose. There are types of structural systems like tensile structure, there are the structures which is very much useful for the stadium or any kind of a arena, which is membrane kind of a structure, very lightweight. There are structures through plates, there are different type of folded plates, arrangements can be possible, and those are the again a kind of a solution for the long span structural systems also. So, based on that, we have a kind of understanding of the different type of structural systems. Now, let us going to in the last one, that is the what are the objective of our structural engineering. The first objective is definitely the safety. The safety is the first. See, a child is sitting on a particular chair, a bench. Okay, so, that particular bench has to take care of the load. The four legs of that particular thing has to be thick, the thickness and the strength has to be such a way that it can take the load of that particular child. There should not be any kind of a cracking, which is given in the next photograph, that this huge cracks definitely is going to have the bad impact on particular structure, and definitely structure will going to fail. I mean, after failure those kind of a crack will appear. So, safety is the first concern. Then the stability, you see a girl is pushing a particular table. So, when you push a particular thing from the other direction, it should not be topple or buckle or maybe slide or so. So, a structure should be have kind of stability. The strength comes from the downward or the gravity loads point of view, and the stability comes from the transverse or the lateral load point of view. The second photograph, if you see, it is a building which is I mean the tilted because of the earthquake. So, it should not be, it should have that kind of a strength, some kind of a bearing and some kind of a gripping through the foundations or so, it should not be unstable. Then there are serviceability kind of a thing, it may be stable, it may be having sufficient amount of safety, but sometimes the serviceability is not there, the beam and the floor is deflected. So, if it is deflected, you cannot have some kind of activity over that. You cannot put a chair, you cannot put some kind of a table, it will create a lot of problem while walking or those kind of scenarios or so. Sometimes it will give you some kind of a psychological problems also, you may feel that the building is unsafe. So, those kind of the serviceability criteria also has to be fulfilled. Then definitely there are durability criteria also, there are for a you will design a structure for 80 or 100 years or so. So, you have to see the how much it can be resistance to the corrosion, creep and shrinkage are the kind of the age phenomena which comes from the particular when the material is getting old and reduce its particular strength or so. And then there are the another objective is the economy. So, you have to see that the how the efficiently you can use the structural systems such a way that it will give you the you can design this within your budget. There are other parameters like objective like the ease of maintenance is another issue, because you have to actually maintain, you cannot actually say that the structure once is built it is forever. Also the fire resistance is another issue. And finally, this is the important issue for our case is the aesthetics. A structural system should also impart aesthetics to the structure, I mean the building. Otherwise, if it goes other way around, it will going to give you a lot of problems. So, I have written that one, that a engineer plays a major role to translate the imagination of an architect to in the grounded into the reality to the through the structural systems. So, if you have a wonderful compositions like the Taj Mahal or maybe the Pyramid of Giza, those are the very wonderful compositions of the simple erected structure with a very systematic and the way it has been designed. Definitely your structural handling the structural systems for that also will be ease. So, I should not say that you should always go with the symmetrical buildings also, it may be of asymmetry, but you have to look into that how those asymmetry can be taken into a particular the composed and unique way in a structural systems also. So, I written in the last that it indeed a challenge and a responsibility of a structural engineer to design a structure for appropriate for the appropriate architectural purpose, and also should have a right balance between the safety and the economy. So, about the course, as we told you, this is the 8-week course. So, total 40 lectures and PPTs and the handouts will be delivered. I will give some kind of the home worksheet also, and in that particular after each and every lecture, and whenever it is possible, I will give some kind of a homework for you, and the tentative solutions or some hint of that particular homework will be available in your forum. So, we have some assignment also, we have 8 assignment for the 8 weeks. We have we can discuss through our forums, 2 of our TA, the teaching assistants will help you for this particular discussion, and definitely we will have a end semester examination after end of the 8-week program and also. So, I have taken the reference of these 2 books, and this is the concluding remarks for that, and we have already discussed all the systems of structural systems and the objective, and my next lecture will be on the force system in the same module. Thank you very much.